Welcome back to Numericals in Electrostatics Part 6. Here the question. A block of mass m is equal to 4 kg and charge q is equal to 50 microcoulomb is connected to a spring having force constant k is equal to 100 Newton meter minus 1. The block lies on a frictionless horizontal track and uniform electric field E is equal to 5 into 10 to the power of 5 Newton meter minus 1 acts on system as shown. In the figure it's shown along the x direction, of course. The block is released from rest when spring is unstretched, that is at x is equal to 0. By what maximum amount does the spring expand? What is the equilibrium position of the block? C bit show that the block's motion is SHM and determine its amplitude and time period. When we are going to solve the problem, just before solving the problem, we recollect what are the various forces acting on this one. If you see, the charge is Q on the block mass M and the spring is connected and the block is moving on frictionless surface. So the electric field is acting towards x positive direction. When this electric field is acting, what happens? If you see, electric field is acting on the block, the electrostatic force is acting along the x positive, and one more we can see the other force which we are talking about. What are the other forces that you can guess here? That is the elastic spring force. Elastic force, what we call elastic spring force here. So now see, the block when at x is equal to x0, that is nothing but mean position. Over there, this electrostatic force, because of the electrostatic force, the block is moving towards x direction. So the electrostatic force F is equal to QE is acting, and the spring, due to the extension of the spring x, the spring force is acting towards the minus x, means towards the left the spring force is acting, towards the right the electrostatic force is acting. Now due to this electrostatic force, the block is moving towards x positive direction. So work is done. What kind of work is done here? The work is done by the electrostatic force is equivalent to the work done by the spring force, because this block when it is moving, it is stretching the spring, means its usual length is increased, enhanced to x maximum. X0 is the mean position. So x maximum, when it is going to the x maximum, the work done by electrostatic force is equivalent to elastic potential energy at extreme position x maximum. Due to this, what is happening again, when it reaches to the extreme position x maximum, the net displacement here gets 0. When we are talking about this electrostatic force, how much electrostatic force is acting? So this is getting displaced from its mean position to x maximum. So mean position to x maximum, that work done is equivalent to force into displacement according to the formula that we know. The force is here QE and the displacement is x maximum, QE into x maximum, which is equivalent to extreme position half kx square maximum, because the spring is also stretched, maximum displacement x maximum. So x increases, electric force QE will accelerate the block while spring force kx will oppose the motion. The block will come to rest when it is goes to the extreme position. What we discussed, the same thing here, expressed in mathematically half kx square max is equal to QE into x max, where QE is the force acting on the charge Q. From this, easily we can calculate maximum x maximum is equal to 2 QE by K. The value is already given in the numerical question. So we put the values, we get the maximum displacement of the block from the normal position is equal to 0.5 meter. From the question, the first bit is over. By what maximum amount does the spring expand? X maximum we just now calculated. The second bit, B. What is the equilibrium position of the block? To calculate this, first we at equilibrium position, the right side force F is equal to QE and left side force F is equal to KX are equal and opposite. So these two forces equal and opposite at equilibrium. At equilibrium, here see, at equilibrium what is that? If x naught is the stretch of the spring, k x naught is equal to qa. These two forces are equal and opposite. From this, x naught is equal to q by k, which is half k x maximum. X maximum already we calculated. From this, we can substitute here that the value is equal to 0.25. After substitution, we get the answer, final answer. Thank you. Enjoy solving the numericals.